So we talked 3 years ago. I'm curious, in your view, what has been the biggest update of the last 3 years? What has been the biggest difference between what it felt like last 3 years versus now?
Yeah, I would say actually the underlying technology, like the exponential of the technology, has gone broadly speaking, I would say about as I expected it to go. I mean, there's like plus or minus, a couple. There's plus or minus a year or two here. There's plus or minus a year or two there. I don't know that I would have predicted the specific direction of code, but actually, when I look at the exponential, it is roughly what I expected in terms of the march of the models from like, smart high school student to smart college student to like, beginning to do PhD and professional stuff. And in the case of code, reaching beyond that. So, the frontier is a little bit uneven. It's roughly what I expected. I will tell you, though, what the most surprising thing has been. The most surprising thing has been the lack of public recognition of how close we are to the end of the exponential. To me, it is absolutely wild that, you have people, within the bubble and outside the bubble, but you have people talking about these, just the same tired old hot button political issues and like, around us we're like near the end of the exponential.
I want to understand what that exponential looks like right now, because the first question I asked you when we recorded 3 years ago was, what's up with scaling? Why does it work? And I have a similar question now, but I feel like it's a more complicated question because, at least from the public's point of view,
Yes.
3 years ago, there were these, well-known public trends where across many orders of magnitude of compute, you could see how the loss improves. And now we have RL scaling, and there's no publicly known scaling law for it. It's not even clear what exactly the story is this supposed to be teaching the model skills? Is it supposed to be teaching meta learning? What is the scaling hypothesis at this point?
Yeah, so I have actually the same hypothesis that I had even all the way back in 2017. So in 2017, I think I talked about it last time, but I wrote a doc called the big blob of compute hypothesis. And it wasn't about the scaling of language models in particular. When I wrote it, GPT-1 had just come out, right? So that was, one among many things, right? There was back in those days, there was robotics. People tried to work on reasoning as a separate thing from language models. There was scaling of the kind of RL that happened, that kind of happened in AlphaGo, and that happened at Dota at OpenAI, and people remember StarCraft at DeepMind, the Alpha Star. So it was written as a more general document, and the specific thing I said was the following. It's very, Rich Sutton put out the bitter lesson a couple years later, but the hypothesis is basically the same. So what it says is all the cleverness, all the techniques, all the kind of we need a new method to do something like that doesn't matter very much. There are only a few things that matter, and I think I listed 7 of them. One is like how much raw compute you have. The other is the quantity of data that you have. Then the third is kind of the quality and distribution of data, right? It needs to be a broad distribution of data. The fourth is, I think, how long you train for. The fifth is you need an objective function that can scale to the moon. So the pre-training objective function is one such objective function, right? Another objective function is, the kind of RL objective function that says, like, you have a goal, you're going to go out and reach the goal. Within that, of course, there's objective rewards, like you see in math and coding, and there's more subjective rewards, like you see in RL from human feedback, or kind of higher order versions of that. And then the 6th and 7th were things around kind of like normalization or conditioning, like, just getting the numerical stability so that kind of the big blob of compute flows in this laminar way instead of running into problems. So that was the hypothesis, and it's a hypothesis I still hold. I don't think I've seen very much that is not in line with that hypothesis. And so the pre-training scaling laws were one example of kind of what we see there. And indeed, those have continued going. Like, I think now it's been widely reported, like, we feel good about pre-training. Like, pre-training is continuing to give us gains. What has changed is that now we're also seeing the same thing for RL, right? So we're seeing a pre-training phase, and then we're seeing like an RL phase on top of that. And with RL, it's actually just the same. Like, even other companies have published in some of their releases have published things that say, look, we train the model on math contests, 𝐒𝐈𝐌𝐒𝐄𝐄 or the kind of other things, and how well the model does is log linear in how long we've trained it. And we see that as well. And it's not just math contests, it's a wide variety of RL tasks. And so we're seeing the same scaling in RL that we saw for pre-training.
You mentioned Richard Sutton and the bitter lesson.
Yeah.
I interviewed him last year, and he is actually very non-LLM pilled. And I don't know if this is his perspective, but one way to paraphrase this objection is something like, look, something which possesses the true core of human learning would not require all these billions of dollars of data and compute and these bespoke environments to learn how to use Excel or how to use PowerPoint, how to navigate a web browser. And the fact that we have to build in these skills using these RL environments hints that we're actually lacking this core human learning algorithm. And so we're scaling the wrong thing. And so, yeah, that does raise the question, why are we doing all this RL scaling if we do think there's something that's going to be human-like in its ability to learn on the fly?
Yeah. So I think this kind of puts together several things that should be kind of thought of differently.
Yeah.
I think there is a genuine puzzle here, but it may not matter. In fact, I would guess it probably doesn't matter. So let's take the RL out of it for a second, because I actually think RL, and it's a red herring to say that RL is any different from pre-training in this matter. So if we look at pre-training scaling, it was very interesting. Back in 2017, when Alec Radford was doing GPT-1, if you look at the models before GPT-1, they were trained on these data sets that didn't represent a wide, distribution of text, right? You had these very standard, kind of language modeling benchmarks. And GPT-1 itself was trained on a bunch of, I think it was fan fiction, actually. But it was like literary, it was like literary text, which is a very small fraction of the text that you get. And what we found with that, and in those days it was like 1 billion words or something. So small data sets and represented a pretty narrow distribution, right? Like a narrow distribution of kind of what you can see in the world. And it didn't generalize well. If you did better on I forget what it was, some kind of fan fiction corpus. It wouldn't generalize that well to kind of the other we had all these measures of how well does the model do at predicting all of these other kinds of texts. You really didn't see the generalization. It was only when you trained over all the tasks on the the internet, when you kind of did a general internet scrape, right, from something like Common Crawl or scraping links on Reddit, which is what we did for GPT-2. It's only when you do that you kind of started to get generalization. And I think we're seeing the same thing on RL, that we're starting with first very simple RL tasks like training on math competitions. Then we're kind of moving to, kind of broader training that involves things like code as a task. And now we're moving to do kind of many other tasks. And then I think we're going to increasingly get generalization. So that kind of takes out the RL versus the pre-training side of it. But I think there is a puzzle here either way, which is that on pre-training, when we train the model on pre-training, we use like trillions of tokens, right? And humans don't see trillions of words. So there is an actual sample efficiency difference here. There is actually something different that's happening here, which is that the models start from scratch and, they have to get much more training. But we also see that once they're trained, if we give them a long context length, the only thing blocking a long context length is like inference. But if we give them like a context length of 1 million, they're very good at learning and adapting within that context length. And so I don't know the full answer to this, but I think there's something going on that pre-training, it's not like the process of humans learning. It's somewhere between the process of humans learning and the process of human evolution. It's somewhere between, like we get many of our priors from evolution. Our brain isn't just a blank slate, right? Whole books have been written about. I think the language models, they're much more blank slates. They literally start as like random weights, whereas the human brain starts with all these regions. It's connected to all these inputs and outputs. And so maybe we should think of pre-training, and for that matter, RL as well, as being something that exists in the middle space between human evolution and, kind of human on the spot learning, and as the in context learning that the models do as something between long-term human learning and short-term human learning. So, there's this hierarchy of like, there's evolution, there's long-term learning, there's short-term learning, and there's just human reaction. And the LLM phases exist along this spectrum, but not necessarily exactly at the same points. That there's no analog to some of the human modes of learning. The LLMs are kind of falling between the points. Does that make sense?
Yes, although some things are still a bit confusing. For example, if the analogy is that this is like evolution, so it's fine that it's not that sample efficient, then like, well, if we're going to get the kind of super sample efficient agent from in-context learning, why are we bothering to build in, there's RL environment companies which are, it seems like what they're doing is they're teaching it how to use this API, how to use Slack, how to use whatever. It's confusing to me why there's so much emphasis on that if the kind of agent that can just learn on the fly is emerging or is going to soon emerge or has already emerged.
Yeah. So I mean, I can't speak for the emphasis of anyone else. I can only talk about how we think about it. I think the way we think about it is the goal is not to teach the model every possible skill within RL, just as we don't do that within pre-training, right? Within pre-training, we're not trying to expose the model to, every possible way that words could be put together, right? It's rather that the model trains on a lot of things and then it reaches generalization across pre-training, right? That was the transition from GPT-1 to GPT-2 that I saw up close, which is like, the model reaches a point. I like had these moments where I was like, oh yeah, you just give the model a list of numbers that's like, this is the cost of the house, this is the square feet of the house, and the model completes the pattern and does linear regression. Like, not great, but it does it, but it's never seen that exact thing before. And so to the extent that we are building these RL environments, the goal is very similar to what was done 5 or 10 years ago with pre-training. We're trying to get a whole bunch of data, not because we want to cover a specific document or a specific skill, but because we want to generalize.
I mean, I think the framework you're laying down obviously makes sense. Like, we're making progress towards AGI. I think the crux is something like, nobody at this point disagrees that we're going to achieve AGI in this century. And the crux is, you say we're hitting the end of the exponential, and somebody else looks at this and says, oh, yeah, we're making progress. We've been making progress since 2012, and then 2035 we'll have a human-like agent. And so I want to understand what it is that you're seeing which makes you think, yeah, obviously we're seeing the kinds of things that evolution did or that within the human lifetime learning is like in these models, and why think that it's 1 year away and not 10 years away?
I actually think of it as like there's kind of two cases to be made here, or like two claims you could make, one of which is like stronger and the other of which is weaker. So I think starting with the weaker claim, when I first saw the scaling back in 2019, I wasn't sure. This was this was kind of a 50-50 thing, right? I thought I saw something that was, and my claim was, this is much more likely than anyone thinks it is. Like, this is wild. No one else would even consider this. Maybe there's a 50% chance this happens. On the basic hypothesis of, as you put it, within 10 years, we'll get to, what I call kind of country of geniuses in a data center. I'm at like 90% on that. And it's hard to go much higher than 90% because the world is so unpredictable. Yeah. Maybe the irreducible uncertainty would be if we were at 95%, where you get to things like, I don't know, maybe multiple companies have, kind of internal turmoil and nothing happens, and then Taiwan gets invaded and like all the fabs get blown up by missiles and then
now you've changed the scenario.
Yeah. You could construct a scenario where there's like a 5% chance that you can construct a 5% world where like things get delayed for 10 years. That's maybe 5%. There's another 5%, which is that I'm very confident on tasks that can be verified. So I think with coding, I'm just, except for that irreducible uncertainty, I think we'll be there in 1 or 2 years. There's no way we will not be there in 10 years in terms of being able to do it end-to-end coding. The one little bit of fundamental uncertainty, even on long timescales, is this thing about tasks that aren't verifiable, like planning a mission to Mars, like doing some fundamental scientific discovery like CRISPR, like writing a novel. Hard to verify those tasks. I am almost certain that we have a reliable path to get there, but like if there was a little bit uncertainty, it's there. So on the 10 years, I'm like 90%, which is about as certain as you can be. Like I think it's crazy to say that this won't happen by 2035. Like in some sane world, it would be outside the mainstream.
But the emphasis on verification hints to me as a lack of belief that these models will generalize. If you think about humans,
yes,
we are good at things that both which we get a verifiable reward and things which we don't. You're like, you have
no. This is why I'm almost sure we already see substantial generalization from things that verify to things that don't verify. We're already seeing that.
But it seems like you were emphasizing this as a spectrum which will split apart which domains we see more progress, and I'm like, but that doesn't seem like how humans get better.
The world in which we don't make it, or the world in which we don't get there, is the world in which we do all the things that are verifiable, and then they many of them generalize, but we kind of don't get fully there. We don't fully color in this side of the box. It's not a binary thing.
But it also seems to me, so even if in the world where generalization is weak when you only say verifiable domains, it's not clear to me in such a world you could automate software engineering, because software, like in some sense, you are quote unquote a software engineer.
Yeah.
But part of being a software engineer for you involves writing these like long memos about your grand vision about different things. And
so I don't think that's part of the job of 𝐶𝐕. That's part of the job of the company. But I do think 𝐶𝐕 involves like design documents and other things like that. Which, by the way, the models are not bad. They're already pretty good at writing comments. And so again, I'm making like much weaker claims here than I believe to to kind of set up to distinguish between two things. Like we're already almost there for software engineering. We are already almost there.
By what metric? There's one metric which is like how many lines of code are written by AI.
Yes.
And if you consider other productivity improvements in the course of the history of software engineering, compilers write all the lines of software. But there's a difference between how many lines are written and how big the productivity improvement is.
Oh yeah.
And and then like we're almost there, meaning like how big is the productivity improvement, not just how many lines are written.
Yeah. So I actually agree with you on this. So I've made this series of predictions on code and software engineering, and I think people have repeatedly kind of misunderstood them. So let me lay out the spectrum, right? Like I think it was like 8 or 9 months ago or something, I said, the AI model will be writing 90% of the lines of code in 3 to 6 months, which happened at least at some places, right? Happened at Anthropic, happened with many people downstream using our models. But that's actually a very weak criterion, right? People thought I was saying we won't need 90% of the software engineers. Those things are worlds apart, right? Like I would put the spectrum as 90% of code is written by the model, 100% of code is written by the model, and that's a big difference in productivity. 90% of the end-to-end 𝐶𝐕 tasks, right, including things like compiling, including things like setting up clusters and environments, testing features, writing memos, 90% of the 𝐶𝐕 tasks are written by the models. 100% of today's 𝐶𝐕 tasks are written by the models. And even when that happens, it doesn't mean software engineers are out of a job. There's new higher level things they can do where they can manage. And then there's a further down the spectrum, there's 90% less demand for 𝐶𝐕s, which I think will happen, but this is a spectrum. And I wrote about it in the Adolescence of Technology, where I went through this kind of spectrum with farming. And so I actually totally agree with you on that. It's just these are very different benchmarks from each other, but we're proceeding through them super fast.
It seems like in part of your vision, it's like going from 90 to 100. First, it's going to happen fast, and two, that somehow that leads to huge productivity improvements. Whereas when I notice, even in greenfield projects that people start with Claude Code or something, people report starting a lot of projects, and I'm like, do we see in the world out there a renaissance of software, all these new features that wouldn't exist otherwise? And at least so far, it doesn't seem like we see that. And so that does make me wonder, even if like I never had to intervene on Claude Code, there is this thing of like, there's just, the world is complicated, jobs are complicated, and closing the loop on self-contained systems, whether it's just writing software or something, how much broader gains we would see just from that. And so maybe that makes us, this should dilute our estimation of the country of geniuses.
I simultaneously agree with you, agree that it's a reason why these things don't happen instantly, but at the same time, I think the effect is going to be very fast. So like, I don't know, you could have these two poles, right? One is like, AI is like, it's not going to make progress. It's slow. Like it's going to take, kind of forever to diffuse within the economy, right? Economic diffusion has become one of these buzzwords that's like a reason why we're not going to make AI progress or why AI progress doesn't matter. And the other axis is like, we'll get recursive self-improvement, the whole thing, can't you just draw an exponential line on the curve? We're going to have, Dyson spheres around the sun in like, so many nanoseconds after, after we get recursive. I mean, I'm completely caricaturing the view here, but like, there are these two extremes. But what we've seen from the beginning, at least if you look within Anthropic, there's this bizarre 10x per year growth in revenue that we've seen, right? So, in 2023, it was like 0 to 100 million. 2024, it was 100 million to $1 billion. 2025, it was $1 billion to like 9 or 10 billion. And then
you guys should have just bought like $1 billion worth of your own products so you could just like have a clean 10B.
And the first month of this year, like that exponential is, you would think it would slow down, but it would like, we added another few billion to like, we added another few billion to revenue in January. And so, obviously that curve can't go on forever, right? The GDP is only so large. I would even guess that it bends somewhat this year, but like that is like a fast curve, right? That's like a really fast curve, and I would bet it stays pretty fast even as the scale goes to the entire economy. So like I think we should be thinking about this middle world where things are like extremely fast, but not instant, where they take time because of economic diffusion, because of the need to close the loop, because, it's like this fiddly, oh man, I have to do change management within my enterprise. I have to like, I set this up, but I have to change the security permissions on this in order to make it actually work. Or, I had this like old piece of software that, checks the model before it's compiled and like released, and I have to rewrite it. And yes, the model can do that, but I have to tell the model to do that. And it has to take time to do that. And so I think everything we've seen so far is compatible with the idea that there's one fast exponential that's the capability of the model, and then there's another fast exponential that's downstream of that, which is the diffusion of the model into the economy. Not instant, not slow, much faster than any previous technology, but it has its limits. And this is what we, when I look inside Anthropic, when I look at our customers, fast adoption, but not infinitely fast.
Can I try a hot take on you?
Yeah.
I feel like diffusion is 𝐾𝐄 that people use to say when it's like, if the model isn't able to do something, they're like, oh, but it's like a diffusion issue. But then you should use the comparison to humans. You would think that the inherent advantages that AIs have would make diffusion a much easier problem for new AIs getting onboarded than new humans getting onboarded. So an AI can read your entire Slack and your Drive in minutes. They can share all the knowledge that the other copies of the same instance have. You don't have this adverse selection problem when you're hiring AIs because you can just hire copies of a vetted AI model. Hiring a human is like so much more hassle. And people hire humans all the time, right? We pay humans upwards of $50 trillion in wages because they're useful, even though it's like, in principle, it would be much easier to integrate AIs into the economy than it is to hire humans. I think like the diffusion, I feel like doesn't really explain.
I think diffusion is very real. And and doesn't have to, doesn't exclusively have to do with limitations on the AI models. Like, again, there are people who use diffusion to as kind of a buzzword to say this isn't a big deal. I'm not talking about that. I'm not talking about, AI will diffuse at the speed that previous. I think AI will diffuse much faster than previous technologies have, but not infinitely fast. So I'll just give an example of this, right? Like, there's like Claude Code. Like, Claude Code is extremely easy to set up. If you're a developer, you can kind of just start using Claude Code. There is no reason why a developer at a large enterprise should not be adopting Claude Code as quickly as, an individual developer or developer at a startup. And we do everything we can to promote it, right? We sell Claude Code to enterprises, and big enterprises like, big financial companies, big pharmaceutical companies, all of them, they're adopting Claude Code much faster than enterprises typically adopt new technology, right? But again, it takes time. Like, any given feature or any given product, like Claude Code or like Cowork, will get adopted by the individual developers who are on Twitter all the time, by the Series A startups, many months faster than they will get adopted by a large enterprise that does food sales. There are a number of factors, like you have to go through legal, you have to provision it for everyone. It has to, it has to pass security and compliance. The leaders of the company who are further away from the AI revolution, are forward-looking, but they have to say, oh, it makes sense for us to spend $50 million. This is what this Claude Code thing is. This is why it helps our company. This is why it makes us more productive. And then they have to explain to the people 2 levels below. And they have to say, okay, we have 3,000 developers. Like, here's how we're going to roll it out to our developers. And we have conversations like this every day. Like, we are doing everything we can to make Anthropic's revenue grow 20 or 30x a year instead of 10x a year. And again, many enterprises are just saying, this is so productive, we're going to take shortcuts in our usual procurement process, right? They're moving much faster than, when we tried to sell them just the ordinary API, which many of them use, but Claude Code is a more compelling product. But it's not an infinitely compelling product. And I don't think even AGI or Powerful AI or Country of Geniuses in the data center will be an infinitely compelling product. It will be a compelling product enough maybe to get 3 or 5 or 10x a year growth, even when you're in the hundreds of billions of dollars, which is extremely hard to do and has never been done in history before, but not infinitely fast.
I buy that it would be a slight slowdown, and maybe this is not your claim, but sometimes people talk about this the capabilities are there, but because of diffusion, otherwise, we're basically at AGI, and then
I don't believe we're basically at AGI.
I think if you had the Country of Geniuses in a data center, if your company didn't adopt the Country of Geniuses in a data center,
if you had the Country of Geniuses in a data center, we would know it.
Right? Yeah,
we would know it
yes.
if you had the Country of Geniuses in a data center. Like, everyone in this room would know it. Everyone in Washington would know it. People in rural parts might not know it, but we would know it. We don't have that now. That's very clear.
As Dario was hinting at, to get generalization, you need to train across a wide variety of realistic tasks and environments. For example, with a sales agent, the hardest part isn't teaching it to mash buttons in a specific database in Salesforce. It's training the agent's judgment across ambiguous situations. How do you sort through a database with thousands of leads to figure out which ones are hot? How do you actually reach out? What do you do when you get ghosted? When an AI lab wanted to train a sales agent, Labelbox brought in dozens of Fortune 500 salespeople to build a bunch of different RL environments. They created thousands of scenarios where the sales agent had to engage with the potential customer, which was role-played by a second AI. Labelbox made sure that this customer AI had a few different personas, because when you cold call, you have no idea who's going to be on the other end. You need to be able to deal with a whole range of possibilities. Labelbox's sales experts monitored these conversations turn by turn, tweaking the role-playing agent to ensure it did the kinds of things an actual customer would do. Labelbox could iterate faster than anybody else in the industry. This is super important because RL is an empirical science. It's not a solved problem. Labelbox has a bunch of tools for monitoring agent performance in real time. This lets their experts keep coming up with tasks so that the model stays in the right distribution of difficulty and gets the optimal reward signal during training. Labelbox can do this sort of thing in almost every domain. They've got hedge fund managers, radiologists, even airline pilots. So whatever you're working on, Labelbox can help. Learn more at labelbox.com/Voracash. Coming back to concrete predictions, because I think because there's so many different things to disambiguate, it can be easy to talk past each other when we're talking about capabilities. So, for example, when I interviewed you 3 years ago, I asked you a prediction about what should we expect 3 years from now. And I think you were right. So you said we should expect systems which, if you talk to them for the course of an hour, it's hard to tell them apart from a generally well-educated human.
Yes.
I think you were right about that. And I think spiritually, I feel unsatisfied because my internal expectation was that such a system could automate large parts of white-collar work. And so it might be more productive to talk about the actual end capabilities you want such a system.
So I will basically tell you what you know where I think we are. So,
but let me ask it in a very specific question so that we can figure out exactly what kinds of capabilities we should expect soon. So maybe I'll ask about it in the context of a job I understand well, not because it's the most relevant job, but just because I can evaluate the claims about it. Take video editors, right? I have video editors, and part of their job involves learning about our audience's preferences, learning about my preferences and tastes and the different trade-offs we have, and how just over the course of many months building up this understanding of context. And so the skill and ability they have 6 months into the job, a model that can pick up that skill on the job, on the fly. When should we expect such an AI system?
Yeah. So I guess what you're talking about is like, you know, we're doing this interview for 3 hours, and then like, you know, someone's going to come in, someone's going to edit it. They're going to be like, oh, you know, I don't know, Dario, like, you know, scratched his head, and you know, we could edit that out, and you know,
magnify that.
There was this like long discussion that like is less interesting to people, and then you know, then there's other thing that's like more interesting to people. So you know, let's kind of make this edit. So you know, I think the country of geniuses in a data center will be able to do that. The way it will be able to do that is, you know, it will have general control of a computer screen, right? Like, you know, and you'll be able to feed this in, and it'll be able to also use the computer screen to like go on the web, look at all your previous interviews, like look at what people are saying on Twitter in response to your interviews, like talk to you, ask you questions, talk to your staff, look at the history of kind of edits that you did, and from that, like, do the job.
Yeah.
So I think that's dependent on several things. One, that's dependent, and I think this is one of the things that's actually blocking deployment, getting to the point on computer use where the models are really masters at using the computer, right? And, you know, we've seen this climb in benchmarks, and benchmarks are always, you know, imperfect measures, but like, you know, OS World is, you know, went from, you know, like 5%, you know, like I think when we first released, you know, computer use like a year and a quarter ago, it was like maybe 15%. I don't remember exactly, but we've climbed from that to like 65 or 70%. And you know, there may be harder measures as well, but I think computer use has to pass a point of reliability.
Can I just ask a follow-up on that?
Yeah.
Before we move on to the next point? I often, for years, I've been trying to build different internal LLM tools for myself, and I often have these text in, text out tasks, which should be dead center in the repertoire of these models, and yet I still hire humans to do them, just because if it's something like identify what the best clips would be in this transcript, and maybe they'll do like a 7 out of 10 job at them, but there's not this ongoing way I can engage with them to help them get better at the job the way I could with a human employee. And so that missing ability, even if you solve computer use, would still block my ability to like offload an actual job to them.
Again, this gets back to what to kind of what we were talking about before with learning on the job, where it's very interesting. You know, I think with the coding agents, like I don't think people would say that learning on the job is what is you know, preventing the coding agents from like, you know, doing everything end to end. Like they keep getting better. We have engineers at Anthropic who like don't write any code. And when I look at the productivity, to your previous question, you know, we have folks who say, this GPU kernel, this chip, I used to write it myself, I just have Claude do it. And so there's this enormous improvement in productivity. And I don't know, like when I see Claude code, like familiarity with the code base, or like it, you know, or a feeling that the model hasn't worked at the company for a year, that's not high up on the list of complaints I see. And so I think what I'm saying is we're kind of taking a different path.
Don't you think with coding that's because there's an external scaffold of memory which exists instantiated in the code base, which I don't know how many other jobs have coding made fast progress precisely because it has this unique advantage that other economic activity doesn't.
But when you say that, what you're implying is that by reading the code base into the context, I have everything that the human needed to learn on the job. So that would be an example of, whether it's written or not, whether it's available or not, a case where everything you needed to know you got from the context window, right? And that what we think of as learning, like, oh man, I started this job, it's going to take me 6 months to understand the code base. The model just did it in the context.
Yeah, I honestly don't know how to think about this, because there are people who qualitatively report what you're saying. There was a meter study I'm sure you saw last year,
yes,
where they had experienced developers try to close pull request in repositories that they were familiar with. And those developers reported an uplift. They reported that they felt more productive with the use of these models. But in fact, if you look at their output and how much was actually merged back in, there's a 20% downlift. They were less productive as a result of using these models. And so I'm trying to square the qualitative feeling that people feel with these models versus one, in a macro level, where is this like renaissance of software? And then two, when people do these independent evaluations, why are we not seeing the productivity benefits that we would expect?
Within Anthropic, this is just really unambiguous, right? We're under an incredible amount of commercial pressure, and make it even harder for ourselves because we have all this safety stuff we do that I think we do more than other companies. So like the pressure to survive economically while also keeping our values is just incredible, right? We're trying to keep this 10x revenue curve going. There is zero time for bullshit. There is zero time for feeling like we're productive when we're not. Like, these tools make us a lot more productive. Like, why do you think we're concerned about competitors using the tools? Because we think we're ahead of the competitors, and like, we don't want to excel. We wouldn't be going through all this trouble if this was secretly reducing our productivity. Like, we see the end productivity every few months in the form of model launches. Like, there's no kidding yourself about this. Like, the models make you more productive.
One, that is, people feeling like they're more productive is qualitatively predicted by studies like this. But two, if I just look at the end output, obviously you guys are making fast progress. But the fact, the idea was supposed to be with recursive self-improvement is that you make a better AI, the AI helps you build a better next AI, et cetera,
yes.
et cetera. And what I see instead, if I look at the OpenAI DeepMind, is that people are just shifting around the podium every few months. And maybe you think that stops because you won or whatever. But why are we not seeing the person with the best coding model have this lasting advantage if, in fact, there are these enormous productivity gains from the last coding model?
So no. I mean, I think it's all like, my model of the situation is there's an advantage that's gradually growing. Like, I would say right now, the coding models give maybe, I don't know, a like 15, maybe 20% total factor speed up. Like, that's my view. And 6 months ago, it was maybe 5%. And so it didn't matter. Like, 5% doesn't register. It's now just getting to the point where it's like one of several factors that kind of matters. And that's gonna keep speeding up. And so I think 6 months ago, like, there were several companies that were at roughly the same point because this wasn't a notable factor, but I think it's starting to speed up more and more. I would also say there are multiple companies that write models that are used for code, and we're not perfectly good at preventing some of these other companies from using our models internally. I think everything everything we're seeing is consistent with this kind of snowball model where there's no hard, again, my theme in all of this is like, all of this is soft takeoff, like soft, smooth exponentials, although the exponentials are relatively steep. And so we're seeing this snowball gather momentum where it's like 10%, 20%, 25%, 40%. And as you go, Amdahl's law, you have to get all the like things that are preventing you from closing the loop out of the way. But like, this is one of the biggest priorities within Anthropic.
Stepping back, I think before in the stack we were talking about well, when do we get this on-the-job learning? And it seems like the point you were making, the coding thing is, we actually don't need on-the-job learning. That you can have tremendous productivity improvements, you can have potentially trillions of dollars of revenue for AI companies without this basic human ability. Maybe that's not your claim, you should clarify. But without this basic human ability to learn on the job. But I just look at like, in most domains of economic activity, people say, I hired somebody, they weren't that useful for the first few months, and then over time, they built up the context understanding. It's actually hard to define what we're talking about here. But they got something. And then now they're a power horse and they're so valuable to us. And if AI doesn't develop this ability to learn on the fly, I'm a bit skeptical that we're going to see huge changes to the world without that ability.
So I think two things here, right? There's the state of the technology right now, which is, again, we have these two stages. We have the pre-training and RL stage where you throw a bunch of data and tasks into the models, and then they generalize. So it's like learning, but it's like learning from more data and not learning over kind of one human or one model's lifetime. So again, this is situated between evolution and human learning. But once you learn all those skills, you have them. And just like with pre-training, just how the models know more, if I look at a pre-trained model, it knows more about the history of samurai in Japan than I do. It knows more about baseball than I do. It knows more about, low pass filters and electronics and all of these things. Its knowledge is way broader than mine. So I think even just that may get us to the point where the models are better at kind of better at everything. And then we also have, again, just with scaling the kind of existing setup, we have the in-context learning, which I would describe as kind of like human on-the-job learning, but like a little weaker and a little short term. Like you look at in-context learning, you give the model a bunch of examples, it does get it. There's real learning that happens in context. And like 1 million tokens is a lot. That can be days of human learning, right? If you think about the model, kind of reading 1 million words, it takes me, how long would it take me to read 1 million? I mean, like days or weeks at least. So you have these two things, and I think these two things within the existing paradigm may just be enough to get you the country of geniuses in the data center. I don't know for sure, but I think they're going to get you a large fraction of it. There may be gaps, but I certainly think just as things are, this, I believe, is enough to generate trillions of dollars of revenue. That's one. That's all one. Two is this idea of continual learning, this idea of a single model learning on the job. I think we're working on that too. And I think there's a good chance that in the next year or two, we also solve that. I think you get most of the way there without it. I think the trillions of dollars I think the trillions of dollars a year market, maybe all of the national security implications and the safety implications that I wrote about in Adolescence of Technology can happen without it. But I also think we, and I imagine others, are working on it. And I think there's a good chance that we get there within the next year or two. There are a bunch of ideas. I won't go into all of them in detail, but one is just make the context longer. There's nothing preventing longer context from working. You just have to train at longer context and then learn to serve them at inference. And both of those are engineering problems that we are working on and that I would assume others are working on as well.
Yeah, so this context line increase, it seemed like there was a period from 2020 to 2023 where from GPT-3 to GPT-4 Turbo, there was an increase from like 2,000 context lines to 128K. I feel like for the 2-ish years since then, we've been in the same-ish ballpark.
Yeah.
And when model context lines get much longer than that, people report qualitative degradation in the ability of the model to consider that full context. So I'm curious what you're internally seeing that makes you think like, 10 million context, 100 million context to get human 6-month learning, billion context.
This isn't a research problem. This is an engineering and inference problem, right? If you want to serve long context, you have to like store your entire KV cache. You have to, it's difficult to store all the memory in the GPUs, to juggle the memory around. I don't even know the detail. At this point, this is at a level of detail that I'm no longer able to follow. Although, I knew it in the GPT-3 era of like, these are the weights, these are the activations you have to store. But these days the whole thing is flipped because we have MOE models and kind of all of that. But and this degradation you're talking about, like, again, without getting too specific, like a question I would ask is like, there's two things. There's the context length you train at, and there's a context length that you serve at. If you train at a small context length and then try to serve at a long context length, like maybe you get these degradations. It's better than nothing. You might still offer it, but you get these degradations. And maybe it's harder to train at a long context length. Yeah, so, there's a lot.
I want to, at the same time, ask about, like, maybe some rabbit holes of, like, well, wouldn't you expect that if you had to train on a longer context length, that would mean that you're able to get sort of like less samples in for the same amount of compute. But before, maybe it's not worth diving deep on that. I want to get an answer to the bigger picture question, which is like, okay, so I don't feel a preference for a human editor that's been working for me for 6 months versus an AI that's been working with me for 6 months. What year do you predict that will be the case?
My guess for that is, there's a lot of problems that are basically like, we can do this when we have the country of geniuses in a data center. And so, my picture for that is, again, if you made me guess, it's like 1 to 2 years, maybe 1 to 3 years. It's really hard to tell. I have a strong view, 95% that like all this will happen in 10 years. Like I think that's just a super safe bet.
Yeah.
And then I have a hunch this is more like a 50-50 thing, that it's going to be more like 1 to 2, maybe more like 1 to 3.
So 1 to 3 years. Country of Geniuses, and then the slightly less economically valuable task of editing videos.
It seems pretty economically valuable, let me tell you. It's just there are a lot of use cases like that,
exactly,
right? There are a lot of similar ones.
So you're predicting that within 1 to 3 years. And then generally, Anthropic has predicted that by late 26, early 27, we will have AI systems that are, quote, have the ability to navigate interfaces available to humans doing digital work today, intellectual capabilities matching or exceeding that of Nobel Prize winners, and the ability to interface with the physical world. And then you gave an interview 2 months ago with DealBook, where you were emphasizing your company's more responsible compute scaling as compared to your competitors. And I'm trying to square these two views where if you really believe that we're going to have a country of geniuses, you want as big a data center as you can get. There's no reason to slow down. The TAM of a Nobel Prize winner that is actually can do everything a Nobel Prize winner can do is like trillions of dollars. And so I'm trying to square this conservatism, which seems rational if you have more moderate timelines, with your stated views about AI progress.
Yeah, so it actually all fits together. And we go back to this fast, but not infinitely fast diffusion. So like, let's say that we're making progress at this rate. The technology is making progress this fast. Again, I have, very high conviction that like it's going, we're going to get there within a few years. I have a hunch that we're going to get there within a year or two. So a little uncertainty on the technical side, but like, pretty strong confidence that it won't be off by much. What I'm less certain about is, again, the economic diffusion side. Like, I really do believe that we could have models that are a country of geniuses in a data center in 1 to 2 years. One question is, how many years after that do the trillions the trillions in revenue start rolling in? I don't think it's guaranteed that it's going to be immediate. I think it could be 1 year, it could be 2 years. I could even stretch it to 5 years, although I'm skeptical of that. And so we have this uncertainty, which is, even if the technology goes as fast as I suspect that it will, we don't know exactly how fast it's going to drive revenue. We know it's coming, but with the way you buy these data centers, if you're off by a couple years, that can be ruinous. It is just like how I wrote, in Machines of Loving Grace, I said, look, I think we might get this powerful AI, this country of genius in the data center. That description you gave comes from the Machines of Loving Grace. I said, we'll get that 2026, maybe 2027. Again, that is my hunch. Wouldn't be surprised if I'm off by a year or two, but like, that is my hunch. let's say that happens. That's the starting gun. How long does it take to cure all the diseases, right? That's one of the ways that like drives a huge amount of economic value, right? Like you cure every disease. There's a question of how much of that goes to the pharmaceutical company, to the AI company, but there's an enormous consumer surplus because everyone, assuming we can get access for everyone, which I care about greatly, we cure all of these diseases. How long does it take? You have to do the biological discovery. You have to, manufacture the new drug. You have to, go through the regulatory process. I mean, we saw this with like vaccines and COVID, right? Like there's just this, we got the vaccine out to everyone, but it took a year and a half, right? And so my question is, how long does it take to get the cure for everything, which AI is the genius that can, in theory, invent, out to everyone? How long from when that AI first exists in the lab to when diseases have actually been cured for everyone, right? We've had a polio vaccine for 50 years. We're still trying to eradicate it in the most remote corners of Africa. And, the Gates Foundation is trying as hard as they can. Others are trying as hard as they can. But, that's difficult. I don't expect most of the economic diffusion to be as difficult as that, right? That's like the most difficult case. But there's a real dilemma here, and where I've settled on it is it will be faster than anything we've seen in the world, but it still has its limits. And so then when we go to buying data centers, the curve I'm looking at is okay. We've had a 10x a year increase every year. So beginning of this year, we're looking at 10 billion in annual rate of annualized revenue at the beginning of the year. We have to decide how much compute to buy. It takes a year or two to actually build out the data centers, to reserve the data centers. So basically I'm saying like in 2027, how much compute do I get? Well, I could assume that the revenue will continue growing 10x a year, so it'll be 100 billion at the end of 2026 and 1 trillion at the end of 2027. And so I could buy $1 trillion. Actually, it would be like $5 trillion of compute because it would be $1 trillion a year for 5 years, right? I could buy $1 trillion of compute that starts at the end of 2027. And if my revenue is not $1 trillion, if it's even 800 billion, there's no force on earth. There's no hedge on earth that could stop me from going bankrupt if I buy that much compute. And so even though a part of my brain wonders if it's going to keep growing 10x, I can't buy $1 trillion a year of compute in 2027. If I'm just off by a year in that rate of growth, or if the growth rate is 5x a year instead of 10x a year, then you go bankrupt. And so you end up in a world where you're supporting hundreds of billions, not trillions, and you accept some risk that there's so much demand that you can't support the revenue, and you accept still some risk that you got it wrong and it's still slow. And so when I talked about behaving responsibly, what I meant actually was not the absolute amount. That actually was not. I think it is true we're spending somewhat less than some of the other players. It's actually the other things like, have we been thoughtful about it? Or are we YOLOing and saying, oh, we're going to do $100 billion here, $100 billion there? I kind of get the impression that, some of the other companies have not written down the spreadsheet, that they don't really understand the risks they're taking. They're just kind of doing stuff because it sounds cool. And we've thought carefully about it, right? We're an enterprise business. Therefore, we can rely more on revenue. It's less fickle than consumer. We have better margins, which is the buffer between buying too much and buying too little. And so I think we bought an amount that allows us to capture pretty strong upside worlds. It won't capture the full 10x a year. And things would have to go pretty badly for us to be in financial trouble. So I think we've thought carefully and we've made that balance. And that's what I mean when I say that we're being responsible.
Okay, so it seems like it's possible that we actually just have different definitions of the country of a genius in a data center. Because when I think of like actual human geniuses, an actual country of human geniuses in a data center, I'm like, I would happily buy $5 trillion worth of compute to run actual country of human geniuses in data centers. So let's say JP Morgan or Moderna or whatever doesn't want to use them. Also, I've got a country of geniuses. Like they'll start their own company. And if like they can't start their own company and they're bottlenecked by clinical trials, it is worth stating with clinical trials, like most clinical trials fail because the drug doesn't work. There's not efficacy, right?
And I make exactly that point in Machines of Love and Grace. I say the clinical trials are going to go much faster than we're used to, but not infinitely fast.
And then suppose it takes a year for the clinical trials to work out so that you're getting revenue from that and you can make more drugs. Okay, well, you've got a country of geniuses and you're an AI lab and you could use many more AI researchers. You also think that there's these like self-reinforcing gains from smart people working on AI tech. So like, okay, you can have
That's right, but
you can have the data center working on like AI progress.
Is there more gains from buying like substantially more gains from buying $1 trillion a year of compute versus $300 billion a year of compute?
If your competitor's buying $1 trillion, yes, there is.
Well, no, there's some gain, but again, there's this chance that they go bankrupt before, again, if you're off by only a year, you destroy yourselves. That's the balance. We're buying a lot. We're buying a hell of a lot. Like we're buying an amount that's comparable to that the biggest players in the game are buying. But if you're asking me why haven't we signed 10 trillion of compute starting in mid 2027? First of all, it can't be produced. There isn't that much in the world. But second, what if the country of geniuses comes, but it comes in mid 2028 instead of mid 2027? You go bankrupt.
So if your projection is 1 to 3 years, it seems like you should want $10 trillion of compute by 2029,
2020, maybe 2020.
Latest.
Like, I mean, you.
But like, are you unsure? Like, it seems like even in the longest version of the timelines you state, the compute you are ramping up to build doesn't seem in accordance.
What makes you think that?
Well, you, as you said, you want the $10 trillion. Like human wages, let's say, are on the order of $50 trillion a year.
If you look at so I won't talk about Anthropic in particular, but if you talk about the industry, like the amount of compute the industry the amount of compute the industry's building this year is probably in the I don't know, very low tens of call it 10, 15 gigawatts. Next year, it goes up by roughly 3x a year. So like next year's 30 or 40 gigawatts, and 2028 might be 100. 2029 might be like 300 gigawatts, and like each gigawatt costs like maybe 10. I mean, I'm doing the math in my head, but each gigawatt costs maybe $10 billion. Or order $10 to $15 billion a year. So. You put that all together and you're getting about what you described. You're getting multiple trillions a year by 2028 or 2029. So you're getting exactly that. You're getting exactly what you predict.
That's for the industry.
That's for the industry. That's right.
So suppose Anthropic's compute keeps 3xing a year, and then by like 27 you have, or 27, 28 you have 10 gigawatts, and like multiply that by, as you say, 10 billion. So then it's like 100 billion a year. But then you're saying the TAM by 2028,
again,
29.
I don't want to give exact numbers for Anthropic, but these numbers are too small. These numbers are too small.
Okay, interesting. I'm really proud that the puzzles I've worked on with Jane Street have resulted in them hiring a bunch of people from my audience. Well, they're still hiring, and they just sent me another puzzle. For this one, they spent about 20,000 GPU hours training backdoors into 3 different language models. Each one has a hidden prompt that elicits completely different behavior. You just have to find the trigger. This is particularly cool because finding backdoors is actually an open question in frontier AI research. Anthropic actually released a couple of papers about sleeper agents, and they showed that you can build a simple classifier on the residual stream to detect when a backdoor is about to fire. But they already knew what the triggers were because they built them. Here, you don't, and it's not feasible to check the activations for all possible trigger phrases. Unlike the other puzzles they made for this podcast, Jane Street isn't even sure this one is solvable, but they've set aside $50,000 for the best attempts and write-ups. The puzzle's live at janestreet.com/Dwarkesh, and they're accepting submissions until April 1st. All right, back to Dario. You've told investors that you plan to be profitable starting in 2028. And this is the year where we're like potentially getting the country of geniuses as a data center. And this is like going to now unlock all this progress in medicine and health and et cetera, and new technologies, wouldn't this be exactly the time where you'd like want to reinvest in the business and build bigger countries so they can make more discoveries?
So I mean, profitability is this kind of like weird thing in this field. I don't think in this field profitability is actually a measure of kind of spending down versus investing in the business. Like let's just take a model of this. I actually think profitability happens when you underestimated the amount of demand you were going to get, and loss happens when you overestimated the amount of demand you were going to get, because you're buying the data centers ahead of time. So think about it this way. Ideally, you would like, and again, these are stylized facts. These numbers are not exact for I'm just trying to make a toy model here. Let's say half of your compute is for training and half of your compute is for inference. And the inference has some gross margin that's like more than 50%. And so what that means is that if you were in steady state, you build a data center, if you knew exactly the demand you were getting, you would you would get a certain amount of revenue. Say, I don't know, let's say you pay $100 billion a year for compute, and on $50 billion a year, you support $150 billion of revenue, and the other $50 billion are used for training. So basically, you're profitable. You make $50 billion of profit. Those are the economics of the industry today, or sorry, not today, but like that's where we're projecting forward in a year or two. The only thing that makes that not the case is if you get less demand than 50 billion. Then you have more than 50% of your data center for research, and you're not profitable. So you train stronger models, but you're like not profitable. If you get more demand than you thought, then your research gets squeezed. But you're kind of able to support more inference, and you're more profitable. So it's maybe I'm not explaining it well, but the thing I'm trying to say is you decide the amount of compute first, and then you have some target desire of inference versus training, but that gets determined by demand. It doesn't get determined by you.
What I'm hearing is the reason you're predicting profit is that you are systematically underinvesting in compute, right? Because if you actually
no. I'm saying it's hard to predict. So these things about 2028 and when it will happen, that's our attempt to do the best we can with investors. All of this stuff is really uncertain because of the cone of uncertainty. Like we could be profitable in 2026 if the revenue grows fast enough, and then if we overestimate or underestimate the next year, that could swing wildly. Like what I'm trying to get at is you have a model in your head of like the business invests, gets scale, and kind of then becomes profitable. There's a single point at which things turn around. I don't think the economics of this industry work that way.
I see. So if I'm understanding correctly, you're saying because of the discrepancy between the amount of compute we should have gotten and the amount of compute we got, we were like sort of forced to make profit. But that doesn't mean we're going to continue making profit. We're going to like reinvest the money because, well, now AI has made so much progress and we want the bigger country of geniuses. And so then back into revenue is high, but losses are also high.
If we predict, if every year we predict exactly what the demand is going to be, we'll be profitable every year. Because spending 50% of your compute on 50% of your compute on research, roughly, plus a gross margin that's higher than 50%, and correct demand prediction leads to profit. That's the profitable business model that I think is kind of like there, but like obscured by these like building ahead and prediction errors.
I guess you're treating the 50% as a sort of like just like a given constant.
Yes.
Whereas
Yes.
in fact, if AI progress is fast and you can increase the progress by scaling up more, you should just have more than 50% and not make profit.
Here's what I'll say. You might want to scale up it more. You might want to scale it up more, but remember the log returns to scale, right? If 70% would get you a very little bit of a smaller model through a factor of 1.4x, right? Like that extra $20 billion is that each dollar there is worth much less to you because the log linear setup. And so you might find that it's better to invest that $20 billion in serving inference or in hiring engineers who are kind of better at what they're doing. So the reason I said 50%, that's not exactly our target. It's not exactly going to be 50%. It will probably vary over time. What I'm saying is the like log linear return, what it leads to is you spend of order one fraction of the business, right? Like not 5%, not 95%, and then you get diminishing returns because of the log.
I feel it's strange that I'm like convincing Dario to like believe in AI progress or something. But like, you don't invest in research because it has diminishing returns, but you invest in the other things you mentioned.
Again, we're talking about diminishing returns after you're spending $50 billion a year, right?
This is a point I'm sure you would make, but like, diminishing returns on a genius could be quite high. And more generally, like, what is profit in a market economy? Profit is basically saying the other companies in the market can like do more things with this money that I can't.
And put aside Anthropic. I'm just trying to like, because I don't want to give information about Anthropic is why I'm giving these stylized numbers. But like, let's just derive the equilibrium of the industry, right? I think so why doesn't everyone spend 100% of their 100% of their compute on training and not serve any customers, right? It's because if they didn't get any revenue, they couldn't raise money, they couldn't do compute deals, they couldn't buy more compute the next year. So there's going to be an equilibrium where every company spends less than 100% on training, and certainly less than 100% on inference. It should be clear why you don't just serve the current models and never train another model, because then you don't have any demand because you'll fall behind. So there's some equilibrium. It's not going to be 10%. It's not going to be 90%. Let's just say as a stylized fact, it's 50%. That's what I'm getting at. And I think we're going to be in a position where that equilibrium of how much you spend on training is less than the gross margins that you're able to get on compute. And so the underlying economics are profitable. The problem is you have this hellish demand prediction problem when you're buying the next year of compute, and you might guess under and be very profitable but have no compute for research, or you might guess over and you are not profitable and you have all the compute for research in the world. Does that make sense? Just as a dynamic model of the industry.
Maybe stepping back, I'm like, I'm not saying I think the country of geniuses is going to come in 2 years and therefore you should buy this compute. To me, what you're saying, the end conclusion you're arriving at makes a lot of sense, but that's because like, oh, it seems like country of geniuses is hard and there's a long way to go. And so the stepping back, the thing I'm trying to get at is more like, it seems like your worldview is compatible with somebody who says, we're like 10 years away from a world in which like we're generating trillions of dollars.
That's just not my view.
Yeah.
That is not my view. Like so I'll make another prediction. It is hard for me to see that there won't be trillions of dollars in revenue before 2030. I can construct a plausible world. It takes maybe 3 years, so that would be the end of what I think it's plausible. Like in 2028, we get the real country of geniuses in a data center. The revenue's been going into the maybe is in the low hundreds of billions by 2028. And then the country of geniuses accelerates it to trillions, and we're basically on the slow end of diffusion. It takes 2 years to get to the trillions. That would be the world where it takes until 2030. I suspect even composing the technical exponential and diffusion exponential will get there before 2030.
So you laid out a model where Anthropic makes profit because it seems like fundamentally we're in a compute-constrained world, and so it's like eventually we keep growing compute.
No, I think the way the profit comes is again, and let's just abstract the whole industry here. Like we have let's just imagine we're in like an economics textbook. Right. We have a small number of firms, each can invest a limited amount in, or like each can invest some fraction in R&D. They have some marginal cost to serve. The margins on that, the gross profit margins on that marginal cost are like very high because inference is efficient. There's some competition, but the models are also differentiated. There's some companies will compete to push their research budgets up, but like because there's a small number of players, we have what is it called? The 𝐶𝐄 equilibrium, I think, is what the small number of firm equilibrium is. The point is, it doesn't equilibrate to perfect competition with zero margins. If there's like three firms in the economy, all are kind of independently behaving rationally, it doesn't equilibrate to zero.
Help me understand that, because right now we do have three leading firms and they're not making profit. And so what is changing?
Yeah. So the gross margins right now are very positive. What's happening is a combination of two things. One is we're still in the exponential scale-up phase of compute.
Yeah.
So what that means is we're training, like a model gets trained.
Yeah.
It costs, let's say a model got trained that costs $1 billion last year. And then this year it produced $4 billion of revenue and cost $1 billion to inference from. So again, I'm using stylized number here, but that would be 75% gross margins and this 25% tax. So that model as a whole makes $2 billion. But at the same time, we're spending $10 billion to train the next model because there's an exponential scale up. And so the company loses money. Each model makes money, but the company loses money. The equilibrium I'm talking about is an equilibrium where we have the country of geniuses. We have the country of geniuses in a data center, but that model training scale up has equilibrated more. Maybe it's still going up. We're still trying to predict the demand, but it's more leveled out.
I'm confused a couple of things there. So let's start with the current world. In the current world, you're right that, as you said before, if you treat each individual model as a company, it's profitable. But
yes.
Of course, a big part of the production function of being a frontier lab is training the next model, right? So
yes, that's right.
If you didn't do that, then you'd make profit for 2 months.
That's
and
right.
then you wouldn't have margins because you wouldn't have the best model. And then you can make profits for 2 months on the current system.
At some point that reaches the biggest scale that it can reach. And then in equilibrium, we have algorithmic improvements, but we're spending roughly the same amount to train the next model as we spent to train the current model.
So this equilibrium relies.
I mean, at some point you run out of money in the economy.
A fixed lump of labor fallacy. The economy is going to grow, right? That's one of your predictions.
Well,
we're going to have
but this is
data centers in space.
But this is another example of the theme I was talking about, which is that the economy will grow much faster with AI than I think it ever has before. But it's not like right now the compute is growing 3x a year.
Yeah.
I don't believe the economy is going to grow 300% a year. Like I said this in Machines of Love and Grace. Like I think we may get 10 or 20% per year growth in the economy, but we're not going to get 300% growth in the economy. So I think in the end, if compute becomes the majority of what the economy produces, it's going to be capped by that.
So now let's assume a model where compute stays capped.
Yeah.
The world where frontier labs are making money is one where they continue to make fast progress, because fundamentally your margin is limited by how good the alternative is. And so you are able to make money because you have a frontier model. If you didn't have a frontier model, you wouldn't be making money.
Well,
so this model requires there never to be a steady state. Like forever and ever, you keep making more algorithmic progress.
I don't think that's true. I mean, I feel like I feel like this is an economics, this is like an economics class.
Do you know the Tyler Cowen quote? We never stop talking about economics.
We never stop talking about economics. So no, but there are worlds in which so I don't think this field's going to be a monopoly. All my lawyers never want me to say the word monopoly. But I don't think this field's going to be a monopoly. But you get industries in which there are a small number of players, not one, but a small number of players. And ordinarily, like the way you get monopolies like Facebook or Meta, or I always call them Facebook, but is these kind of network effects.
Yeah.
The way you get industries in which there are a small number of players are very high costs of entry, right? So Claude is like this. I think Claude is a good example of this. You have 3, maybe 4 players within Claude. I think that's the same for AI. 3, maybe 4. And the reason is that it's so expensive. It requires so much expertise and so much capital to run a cloud company, right? And so you have to put up all this capital, and then in addition to putting up all this capital, you have to get all of this other stuff that requires a lot of skill to make it happen. And so it's like, if you go to someone and you're like, I want to disrupt this industry, here's $100 billion. You're like, okay, I'm putting $100 billion and also betting that you can do all these other things that these people have been doing.
Only to decrease the profit in the industry.
And then the effect of your entering is the profit margins go down. So we have equilibria like this all the time in the economy, where we have a few players. Profits are not astronomical, margins are not astronomical, but they're not zero, right? And I think that's what we see on Claude. Claude is very undifferentiated. Models are more differentiated than Claude, right? Like, everyone knows Claude is good at different things than GPT is good at, than Gemini is good at. And it's not just Claude's good at coding, GPT is good at math and reasoning. It's more subtle than that. Like, models are good at different types of coding. Models have different styles. Like, I think these things are actually quite different from each other. And so I would expect more differentiation than you see in Claude. Now, there actually is a counter. There is one counter argument, and that counter argument is that if all of that, the process of producing models, becomes if AI models can do that themselves, then that could spread throughout the economy. But that is not an argument for commoditizing AI models in general. That's kind of an argument for commoditizing the whole economy at once. I don't know what quite happens in that world where basically anyone can do anything, anyone can build anything, and there's no moat around anything at all. I mean, I don't know. Maybe we want that world. Maybe that's the end state here. When kind of AI models can do, when AI models can do everything, if we've solved all the safety and security problems, that's one of the mechanisms for just kind of the economy flattening itself again. But that's kind of far post Country of Geniuses in the data center.
Maybe a finer way to put that potential point is, one, it seems like AI research is especially loaded on raw intellectual power, which will be especially abundant in a world with AGI. And 2, if you just look at the world today, there's very few technologies that seem to be diffusing as fast as AI algorithmic progress. And so that does hint that this industry is sort of structurally diffusive.
So I think coding is going fast, but I think AI research is a superset of coding, and there are aspects of it that are not going fast. But I do think, again, once we get coding, once we get AI models going fast, then AI, that will speed up the ability of AI models to kind of do everything else. So I think while coding is going fast now, I think once the AI models are building the next AI models and building everything else, the whole economy will kind of go at the same pace. I am worried geographically, though. I'm a little worried that just proximity to AI, having heard about AI, that may be one differentiator. And so when I said the 10 or 20% growth rate, a worry I have is that the growth rate could be 50% in Silicon Valley, and parts of the world that are kind of socially connected to Silicon Valley, and not that much faster than its current pace elsewhere. And I think that'd be a pretty messed up world. So one of the things I think about a lot is how to prevent that.
Yeah. Do you think that once we have this Country of Geniuses as a data center, that robotics is sort of quickly solved afterwards? Because it seems like a big problem with robotics is that a human can learn how to teleoperate current hardware, but current AI models can't, at least not in a way that's super productive. And so if we have this ability to learn like a human, should it solve robotics immediately as well?
I don't think it's dependent on learning like a human. It could happen in different ways. Again, we could have trained the model on many different video games, which are like robotic controls, or many different simulated robotics environments, or just, train them to control computer screens and they learn to generalize. So it will happen. It's not necessarily dependent on human-like learning. Human-like learning is one way it could happen. If the model's like, oh, I pick up a robot, I don't know how to use it, I learn. That could happen because we discovered discovering continual learning. That could also happen because we trained the model on a bunch of environments and then generalized, or it could happen because the model learns that in the context length. It doesn't actually matter which way. If we go back to the discussion we had like an hour ago, that type of thing can happen in several different ways.
Yeah.
But I do think when for whatever reason the models have those skills, then robotics will be revolutionized, both the design of robots, because the models will be much better than humans at that, and also the ability to kind of control robots. So we'll get better at building the physical hardware, building the physical robots, and we'll also get better at controlling it. Now, does that mean the robotics industry will also be generating trillions of dollars of revenue? My answer there is yes, but there will be the same extremely fast but not infinitely fast diffusion. So will robotics be revolutionized? Yeah, maybe tack on another year or two. That's the way I think about these
Makes
things.
sense. There's a general skepticism about extremely fast progress. Like here's my view, which is like, it sounds like you are going to solve continual learning one way or another within the matter of years. But just as people weren't talking about continual learning a couple of years ago, and then we realized, oh, why aren't these models as useful as they could be right now, even though they are clearly passing the Turing test and are experts in so many different domains? Maybe it's this thing. And then we solve this thing and we realize, actually, there's another thing that human intelligence can do, and that's a basis of human labor that these models can't do. And then, so why not think there will be more things like this? So I think that like, we've like found the pieces of human intelligence.
Well, to be clear, I mean, I think continual learning, as I've said before, might not be a barrier at all, right? Like, I think we maybe just get there by pre-training generalization and RL generalization. Like, I think there just might not be, there basically might not be such a thing at all. In fact, I would point to the history in ML of people coming up with things that are barriers that end up kind of dissolving within the big blob of compute, right? That, people talked about, how do you have, how do your models keep track of nouns and verbs, and, how do they, they can understand syntactically, but they can't understand semantically. It's only statistical correlations. You can understand a paragraph, but you can't understand a word. There's reasoning. You can't do reasoning, but then suddenly it turns out you can do code and math very well at all. So I think there's actually a stronger history of some of these things seeming like a big deal and then kind of dissolving. Some of them are real. I mean, the need for data is real. Maybe continual learning is a real thing. But again, I would ground us in something like code. Like, I think we may get to the point in like a year or two where the models can just do SWE end to end. Like, that's a whole task. That's a whole sphere of human activity that we're just saying the models can do it now.
When you say end to end, do you mean setting technical direction, understanding the context of the problem,
yes,
and et cetera?
Yes,
okay.
Yes,
So,
I mean all of that.
Interesting. I mean, that is, I feel like AGI complete, which maybe is internally consistent, but it's not like saying 90% of code or 100% of code. It's like the other parts of the job as well.
No. I gave this spectrum: 90% of code, 100% of code, 90% of end-to-end SWE, 100% of end-to-end SWE. New tasks are created for SWEs. Eventually, those get done as well.
Yeah.
But it's a long spectrum there. But we're traversing the spectrum very quickly.
Yeah. I do think it's funny that I've seen a couple of podcasts you've done where the host will be like, but Dwarkesh wrote this essay about the continual learning thing. And it always makes me crack up because you're like, you've been an AI researcher for like 10 years. And I'm sure there's like some feeling of like, okay, so a podcaster wrote an essay. And every interview I get asked about it.
The truth of the matter is that we're all trying to figure this out together.
Yeah.
Right? There are some ways in which I'm able to see things that others aren't. These days, that probably has more to do with like, I can see a bunch of stuff within Anthropic and have to make a bunch of decisions than I have any great research insight that others don't, right? I'm running a 2,500 person company. Like, it's actually pretty hard for me to have concrete research insight, much harder than it would have been, 10 years ago or even 2 or 3 years ago.
As we go towards a world of a full drop-in remote worker replacement, does a API pricing model still make the most sense? And if not, what is the correct way to price AGI or serve AGI?
Yeah, I mean, I think there's going to be a bunch of different business models here, sort of all at once, that are going to be experimented with. I actually do think that the API model is more durable than many people think. One way I think about it is if the technology is kind of advancing quickly, if it's advancing exponentially, what that means is there's always kind of like a surface area of kind of new use cases that have been developed in the last 3 months. And any kind of product surface you put in place is always at risk of sort of becoming irrelevant, right? Any given product surface probably makes sense for our, a range of capabilities of the model, right? The chatbot is already running into limitations of, making it smarter doesn't really help the average consumer that much. But I don't think that's a limitation of AI models. I don't think that's evidence that the models are good enough, and they're them getting better doesn't matter to the economy. It doesn't matter to that particular product. And so I think the value of the API is the API always offers an opportunity, very close to the bare metal, to build on what the latest thing is. And so there's kind of always going to be this, this kind of front of new startups and new ideas that weren't possible a few months ago and are possible because the model is advancing. And so I kind of actually predict that it's going to exist alongside other models, but we're always going to have the API business model because there's always going to be a need for 1,000 different people to try experimenting with the model in a different way, and 100 of them become startups, and 10 of them become big successful startups, and 2 or 3 really end up being the way that people use the model of a given generation. So I basically think it's always going to exist. At the same time, I'm sure there's going to be other models as well. Like, not every token that's output by the model is worth the same amount. Think about, what is the value of the tokens that are like, that the model outputs when someone, calls them up and says, my Mac isn't working or something, the model's like, restart it, right?
Yeah.
And someone hasn't heard that before, but the model said that 10 million times, right? That maybe that's worth like $1 or a few cents or something. Whereas if the model goes to one of the pharmaceutical companies and it says, oh, this molecule you're developing, you should take the aromatic ring from that end of the molecule and put it on that end of the molecule. And if you do that, wonderful things will happen. Like those tokens could be worth tens of millions of dollars, right? So I think we're definitely going to see business models that recognize that. At some point we're going to see pay for results, or in some form, or we may see forms of compensation that are like labor, that kind of work by the hour. I don't know. I think because it's a new industry, a lot of things are going to be tried, and I don't know what will turn out to be the right thing.
What I find, I take your point that people will have to try things to figure out what is the best way to use this blob of intelligence. But what I find striking is Claude Code. So I don't think in the history of startups there has been a single application that has been as hotly competed in as coding agents. And Claude Code is a category leader here. And that seems surprising to me. Like, it doesn't seem intrinsically like Anthropic had to build this. And I wonder if you have an accounting of why it had to be Anthropic, or how Anthropic ended up building an application in addition to the model underlying it.
Yeah, so it actually happened in a pretty simple way, which is we had our own, we had our coding models, which were good at coding. And around the beginning of 2025, I said, I think the time has come where you can have non-trivial acceleration of your own research if you're an AI company by using these models. And of course, you need an interface, you need a harness to use them. And so I encourage people internally, I didn't say this is one thing that, that you have to use. I just said people should experiment with this. And then, this thing, I think it might have been originally called Claude CLI, and then the name eventually got changed to Claude Code internally, was the thing that kind of everyone was using, and it was seeing fast internal adoption. And I looked at it and I said, probably we should launch this externally, right? It's seeing such fast adoption within Anthropic, coding is a lot of what we do, and so we have a audience of many hundreds of people that's in some ways at least representative of the external audience. So it looks like we already have product market fit. Let's launch this thing, and then we launched it, and I think just the fact that we ourselves are kind of developing the model and we ourselves know what we most need to use the model, I think it's kind of creating this feedback loop.
I see. In the sense that let's say a developer at Anthropic is like, it would be better if it was better at this X thing. And then you bake that into the next model that you build.
That's one version of it, but then there's just the ordinary product iteration of we have a bunch of coders within Anthropic. They use Claude Code every day, and so we get fast feedback. That was more important in the early days. Now, of course, there are millions of people using it, and so we get a bunch of external feedback as well. But it's just great to be able to get fast internal feedback. I think this is the reason why we launched a coding model and didn't launch a pharmaceutical company, right? My background's in biology, but we don't have any of the resources that are needed to launch a pharmaceutical company.
So there's been a ton of hype around OpenClaw, and I wanted to check it out for myself. I've got a day coming up this weekend, and I don't have anything planned yet. So I gave OpenClaw a Mercury debit card. I set a couple $100 limit, and I said, surprise me. Okay, so here's the Mac Mini it's on, and besides having access to my Mercury, it's totally quarantined. And I actually felt quite comfortable giving it access to a debit card because Mercury makes it super easy to set up guardrails. I was able to customize permissions, cap the spend, and restrict the category of purchases. I wanted to make sure the debit card worked, so I asked OpenClaw to just make a test transaction, and decided to donate a couple bucks to Wikipedia. Besides that, I have no idea what's gonna happen. I will report back on the next episode about how it goes. In the meantime, if you want a personal banking solution that can accommodate all the different ways that people use their money, even experimental ones like this one, visit mercury.com/personal. Mercury is a fintech company, not an FDIC insured bank. Banking services provided through Choice Financial Group and Column NA, members FDIC. She thinks we're getting coffee and walking around the neighborhood. Let me ask you about now making AI go well. It seems like whatever vision we have about how AI goes well has to be compatible with two things. One is the ability to build and run AIs is diffusing extremely rapidly. And two is that the population of AIs, the amount we have and their intelligence, will also increase very rapidly. And that means that lots of people will be able to build huge populations of misaligned AIs or AIs which are just like companies which are trying to increase their footprint or have weird psyches like Sydney Bing, but now they're superhuman. What is a vision for a world in which we have an equilibrium that is compatible with lots of different AIs, some of which are misaligned, running around?
Yeah. So I think, in the adolescence of technology, I was kind of, skeptical of the balance of power. But I think I was particularly skeptical of, the thing I was specifically skeptical of is you have 3 or 4 of these companies kind of all building models that are kind of derived, derived from the same thing, and that these would check each other, or even that kind of any number of them would check each other. We might live in a offense dominant world where one person or one AI model is smart enough to do something that causes damage for everything else. I think in the short run, we have a limited number of players now, so we can start by within the limited number of players, we need to put in place the safeguards. We need to make sure everyone does the right alignment work. We need to make sure everyone has bioclassifiers. Those are kind of the immediate things we need to do. I agree that that doesn't solve the problem in the long run, particularly if the ability of AI models to make other AI models proliferates, then the whole thing can kind of can become harder to solve. I think in the long run we need some architecture of governance, right? Some architecture of governance that preserves human freedom but kind of also allows us to like, govern the very large number of kind of, human systems, AI systems, hybrid human, hybrid human AI, like, companies or like economic units. So, we're going to need to think about like, how do we protect the world against, bioterrorism? How do we protect the world against like, against mirror life? Like, probably we're going to need to, need some kind of like AI monitoring system that like kind of monitors for all of these things. But then we need to build this in a way that like, preserves civil liberties and like our constitutional rights. So I think just as is anything else, like it's like a new security landscape with a new set of, tools and a new set of vulnerabilities. And I think my worry is if we had 100 years for this to happen all very slowly, we'd get used to it. Like we've gotten used to like, the presence of explosives in society, or like the presence of various, like new weapons, or the presence of video cameras. We would get used to it over 100, and we'd develop governance mechanisms. We'd make our mistakes. My worry is just that this is happening all so fast, and so I think maybe we need to do our thinking faster about how to make these governance mechanisms work.
Yeah. It seems like in an offense-dominant world, over the course of the next century, so the idea is the AI is making the progress that would happen over the next century happen in some period of 5 to 10 years. But we would still need the same mechanisms, or balance of power would be similarly intractable, even if humans were the only game in town. And so I guess we have the advice of AI. It fundamentally doesn't seem like a totally different ballgame here. If checks and balances were going to work, they would work with humans as well. If they aren't going to work, they wouldn't work with AIs as well. And so maybe this just dooms human checks and balances as well. But
again, I think there's some way to make this happen. Like it just the governments of the world may have to work together to make it happen. Like, you may have to talk to AIs about kind of, building societal structures in such a way that like these defenses are possible. I don't know. I mean, this is I don't want to say so far ahead in time, but like so far ahead in technological ability that may happen over a short period of time that it's hard for us to anticipate it in advance.
Speaking of governments getting involved, on December 26th, the Tennessee legislature introduced a bill which said, quote, it would be an offense for a person to knowingly train artificial intelligence to provide emotional support, including through open-ended conversations with a user. And of course, one of the things that Claude attempts to do is be a thoughtful friend, thoughtful, knowledgeable friend. And in general, it seems like we're going to have this patchwork of state laws. A lot of the benefits that normal people could experience as a result of AI are going to be curtailed, especially when we get into the kinds of things you discuss in Machines of Loving Grace, biological freedom, mental health improvements, et cetera, et cetera. It seems easy to imagine worlds in which these get whack-a-moled away by different laws. Whereas bills like this don't seem to address the actual existential threats that you're concerned about. So I'm curious to understand, in the context of things like this, your Anthropic's position against the federal moratorium on state AI laws.
Yes. So I don't know. There's many different things going on at once, right? I think that particular law is dumb. Like, I think it was clearly made by legislators who just probably had little idea what AI models could do and not do. They're like, AI models serving as that just sounds scary. Like I don't want that to happen. So we're not in favor of that, right? But that wasn't the thing that was being voted on. The thing that was being voted on is we're going to ban all state regulation of AI for 10 years, with no apparent plan to do any federal regulation of AI, which would take Congress to pass, which is a very high bar. So the idea that we'd ban states from doing anything for 10 years, and people said they had a plan for federal government, but there was no proposal on the table. There was no actual attempt. Given the serious dangers that I lay out in Adolescence of Technology around things like the, kind of biological weapons and bioterrorism, autonomy risk, and the timelines we've been talking about, like 10 years is an eternity. Like that's a I think that's a crazy thing to do. So if that's the choice, if that's what you force us to choose, then we're gonna choose not to have that moratorium. And I think the benefits of that position exceed the costs, but it's not a perfect position if that's the choice. Now, I think the thing that we should do, the thing that I would support, is the federal government should step in, not saying states you can't regulate, but here's what we're going to do, and states you can't differ from this, right? Like, I think preemption is fine in the sense of saying that federal government says, here's our standard, this applies to everyone, states can't do something different. That would be something I would support if it would be done in the right way. But this idea of states you can't do anything and we're not doing anything either, that struck us as very much not making sense, and I think will not age well. It's already starting to not age well with all the backlash that you've seen. Now, in terms of what we would want, I mean, the things we've talked about are starting with transparency standards, in order to monitor some of these autonomy risks and bioterrorism risks. As the risks become more serious, as we get more evidence for them, then I think we could be more aggressive in some targeted ways and say, hey, AI bioterrorism is really a threat. Let's pass a law that kind of forces people to have classifiers. And I could even imagine, it depends. It depends how serious a threat it ends up being. We don't know for sure. Then we need to pursue this in an intellectually honest way where we say ahead of time, the risk has not emerged yet. But I could certainly imagine with the pace that things are going that, I could imagine a world where later this year we say, hey, this AI bioterrorism stuff is really serious. We should do something about it. We should put it in a federal standard. And if the federal government won't act, we should put it in a state standard. I could totally see that.
I'm concerned about a world where if you just consider the pace of progress you're expecting, the life cycle of legislation, the benefits are, as you say, because of diffusion lag, the benefits are slow enough that I really do think this patchwork on the current trajectory, this patchwork of state laws would prohibit. I mean, having an emotional chatbot friend is something that freaks people out. Then just imagine the kinds of actual benefits from AI we want normal people to be able to experience, from improvements in health and health span and improvements in mental health and so forth. Whereas at the same time, it seems like you think the dangers are already on the horizon, and I just don't see that much. It seems like it would be especially injurious to the benefits of AI as compared to the dangers of AI, and so that's maybe where the cost benefit makes less sense to me.
So there's a few things here, right? I mean, people talk about there being thousands of these state laws. First of all, the vast majority of them do not pass. And the world works a certain way in theory, but like just because a law's been passed doesn't mean it's really enforced, right? The people implementing it may be like, oh my God, this is stupid. It would mean shutting off everything that's ever been built in Tennessee. So very often laws are interpreted in a way that makes them that makes them not as dangerous or not as harmful. On the same side, of course, you have to worry if you're passing a law to stop a bad thing, you had this problem as well.
Yeah.
Look, I mean, my basic view is, if we could decide, what laws were passed and how things were done, which, we're only one small input into that, I would deregulate a lot of the stuff around the health benefits of AI. I think, I don't worry as much about the kind of chatbot laws. I actually worry more about the drug approval process, where I think AI models are going to greatly accelerate the rate at which we discover drugs, and just the pipeline will get jammed up. Like the pipeline will not be prepared to process all of the stuff that's going through it. So, I think reform of the regulatory process to bias more towards, we have a lot of things coming where the safety and the efficacy is actually going to be really crisp and clear. A beautiful thing, really, really crisp and clear, and really, really effective. But and maybe we don't need all this superstructure around it that was designed around an era of drugs that barely work and often have serious side effects. But at the same time, I think we should be ramping up quite significantly the this kind of safety and security legislation. And, like I've said, starting with transparency is my view of trying not to hamper the industry, right? Trying to find the right balance. I'm worried about it. Some people criticize my essay for saying that's too slow. The dangers of AI will come too soon if we do that. Well, basically, I kind of think like the last 6 months and maybe the next few months are going to be about transparency. And then if these risks emerge when we're more certain of them, which I think we might be as soon as later this year, then I think we need to act very fast in the areas that we've actually seen the risk. Like, I think the only way to do this is to be nimble. Now, the legislative process is normally not nimble, but we need to emphasize to everyone involved the urgency of this. That's why I'm sending this message of urgency, right? That's why I wrote Adolescence of Technology. I wanted policymakers to read it. I wanted economists to read it. I want national security professionals to read it. I want decision makers to read it so that they have some hope of acting faster than they would have otherwise.
Is there anything you can do or advocate that would make it more certain that the benefits of AI are better instantiated? Where I feel like you have worked with legislatures to be like, okay, we're going to prevent bioterrorism here away. We're going to increase transparency. We're going to increase whistleblower protection. And I just think by default, the actual the things we're looking forward to here, it just seems very easy. They seem very fragile to different kinds of moral panics or political economy problems.
Yeah, I don't actually. So I don't actually agree that much in the developed world. I feel like, in the developed world, like markets function pretty well, and when there's like a lot of money to be made on something and it's clearly the best available alternative, it's actually hard for the regulatory system to stop it. We're seeing that in AI itself, right? Like a thing I've been trying to fight for is export controls on chips to China, right? And like that's in the national security interests of the US. Like, that's like square within the, the policy beliefs of, almost everyone in Congress of both parties. But I think the case is very clear. The counter arguments against it are, I'll politely call them fishy. And yet it doesn't happen, and we sell the chips because there's so much money. There's so much money riding on it. And that money wants to be made, and in that case, in my opinion, that's a bad thing. But it also applies when it's a good thing. And so I don't think that if we're talking about drugs and benefits of the technology, I am not as worried about those benefits being hampered in the developed world. I am a little worried about them going too slow. And as I said, I do think we should work to speed the approval process in the FDA. I do think we should fight against these chatbot bills that you're describing, right? Described individually, I'm against them. I think they're stupid. But I actually think the bigger worry is a developing world, where we don't have functioning markets, where we often can't build on the technology that we've had. I worry more that those folks will get left behind. And I worry that even if the cures are developed, maybe there's someone in rural Mississippi who doesn't get it as well, right? That's a kind of smaller version of the concern we have in the developing world. And so the things we've been doing are, we work with philanthropists, right? We work with folks who deliver, medicine and health interventions to developing world, to sub-Saharan Africa, India, Latin America, other developing parts of the world. That's the thing I think that won't happen on its own.
You mentioned export controls.
Yeah.
Why can't the U.S. and China both have a country of geniuses on a data center?
Why can't, why won't it happen, or why shouldn't
No, like why shouldn't it happen?
Why shouldn't it happen? I think if this does happen, then we kind of have we could have a few situations. If we have like an offense dominant situation, we could have a situation like nuclear weapons, but like more dangerous, right? Where it's like, kind of either side could easily destroy everything. We could also have a world where it's unstable. Like the nuclear equilibrium is stable, right? Because it's like deterrence. But let's say there were uncertainty about like if the two AIs fought, which AI would win. that could create instability, right? You often have conflict when the two sides have a different assessment of their likelihood of winning, right? If one side is like, oh yeah, there's a 90% chance I'll win, and the other side's like, there's a 90% chance I'll win, then a fight is much more likely. They can't both be right, but they can both think that.
But this seems like a fully general argument against the diffusion of AI technology, which that's the implication of this world.
Let me just go on, because I think we will get diffusion eventually. The other concern I have is that the governments will oppress their own people with AI, and so I'm worried about some world where you have a country that's already there's a government that kind of already is kind of building a high tech authoritarian state. And to be clear, this is about the government. This is not about the people. Like people, we need to find a way for people everywhere to benefit. My worry here is about governments. So yeah, my worry is if the world gets carved up into two pieces, one of those two pieces could be authoritarian or totalitarian in a way that's very difficult to displace. Now, will governments eventually get powerful AI? And there's risk of authoritarianism. Yes. Will governments eventually get powerful AI? And there's risk of kind of bad equilibria. Yes, I think both things, but the initial conditions matter, right? At some point we're going to need to set up the rules of the road. I'm not saying that one country, either the United States or a coalition of democracies, which I think would be a better setup, although it requires more international cooperation than we currently seem to want to make. But I don't think a coalition of democracies or certainly one country should just say these are the rules of the road. There's going to be some negotiation, right? The world is going to have to grapple with this. And what I would like is that the democratic nations of the world, those with whose governments represent closer to pro-human values, are holding a stronger hand then, have more leverage when the rules of the road are set. And so I'm very concerned about that initial condition.
I was re-listening to an interview from 3 years ago, and one of the ways it aged poorly is that I kept asking questions, assuming there was going to be some key fulcrum moment 2 to 3 years from now, when in fact, being that far out, it just seems like progress continues, AI improves, AI is more diffused, and people will use it for more things. It seems like you're imagining a world in the future where the countries get together and here's the rules of the road and here's the leverage we have, here's the leverage you have. When it seems like on current trajectory, everybody will have more AI. Some of that AI will be used by authoritarian countries. Some of that within the authoritarian countries will be used by private actors versus state actors. It's not clear who will benefit more. It's always unpredictable to tell in advance. It seems like the internet privileged authoritarian countries more than you would have expected. And maybe the AI will be the opposite way around. So I want to better understand what you're imagining here.
Yeah. So just to be precise about it, I think the exponential of the underlying technology will continue as it has before, right? The models get smarter and smarter. Even when they get to country of geniuses in a data center, I think you can continue to make the model smarter. There's a question of like getting diminishing returns on their value in the world, right? How much does it matter after you've already solved human biology, or at some point you can do harder math, you can do more abstruse math problems, but nothing after that matters. But putting that aside, I do think the exponential will continue, but there will be certain distinguished points on the exponential, and companies, individuals, countries will reach those points at different times. And so, there's could there be some, I talk about, is a nuclear deterrent still, in adolescence of technology, is a nuclear deterrent still stable in the world of AI? I don't know, but that's an example of like one thing we've taken for granted, that like the technology could reach such a level that it's no longer like, we can no longer be certain of it, at least. Think of others. There are kind of points where if you reach a certain point, you have offensive cyber dominance, and like every computer system is transparent to you after that, unless the other side has a kind of equivalent defense. So I don't know what the critical moment is, or if there's a single critical moment, but I think there will be either a critical moment, a small number of critical moments, or some critical window where it's like AI confers some large advantage from the perspective of national security, and one country or coalition has reached it before others. I'm not advocating that they're just like, okay, we're in charge now. Or that's not how I think about it. That there's always the other side is catching up. There's extreme actions you're not willing to take, and it's not right to take complete control anyway. But at the point that happens, I think people are going to understand that the world has changed, and there's going to be some negotiation, implicit or implicit, about what is the post-AI world order look like? And I think my interest is in, making that negotiation be one in which, classical liberal democracy has a strong hand.
Well, I want to understand what that better means, because you say in the essay, quote, "Autocracy is simply not a form of government that people can accept in the post-powerful AI age." And that sounds like you're saying the CCP as an institution cannot exist after we get AGI. And that seems like a very strong demand, and it seems to imply a world where the leading lab or the leading country will be able to, and by that language should, get to determine how the world is governed or what kinds of governments are allowed and not allowed.
Yeah. So when I believe that paragraph was, I think I said something like, you could take it even further and say X. So I wasn't necessarily endorsing that I wasn't necessarily endorsing that view. I was saying, like, here's a weaker thing that I believe. I think I said, we have to worry a lot about authoritarians, right, and we should try and kind of check them and limit their power. Like, you could take this kind of further, much more interventionist view that says, like, authoritarian countries with AI are these, these kind of self-fulfilling cycles that you can't, that are very hard to displace, and so you just need to get rid of them from the beginning. That has exactly all the problems you say, which is, if you were to make a commitment to overthrowing every authoritarian country, I mean, they would take a bunch of actions now that, like,
right,
that could lead to instability. So that may or that just may not be possible. But the point I was making that I do endorse is that it is quite possible that, today, the view, or at least my view, or the view in most of the Western world is democracy is a better form of government than authoritarianism. But it's not like, if a country's authoritarian, we don't react the way we reacted if they committed a genocide or something, right? And I guess what I'm saying is I'm a little worried that in the age of AGI, authoritarianism will have a different meaning. It will be a graver thing, and we have to decide one way or another how to deal with that. And the interventionist view is one possible view. I was exploring such views. It may end up being the right view. It may end up being too extreme to be the right view. But I do have hope, and one piece of hope I have is there is. We have seen that as new technologies are invented, forms of government become obsolete. I mentioned this in Adolescence of Technology, where I said, like, feudalism was basically, like a form of government, right? And then when we invented industrialization, feudalism was no longer sustainable. It no longer made sense.
Why is that hope? Why couldn't that imply that democracy is no longer going to be a competitive system?
It could, right? It could go either way, right? But these problems with authoritarianism, right? That the problems with authoritarianism get deeper. I wonder if that's an indicator of other problems that authoritarianism will have, right? In other words, because authoritarianism becomes worse, people are more afraid of authoritarianism. They work harder to stop it. It's more of like, you have to think in terms of total equilibrium, right? I just wonder if it will motivate new ways of thinking about, with the new technology, how to preserve and protect freedom. And even more optimistically, will it lead to a collective reckoning and, a kind of a more emphatic realization of how important some of the things we take as individual rights are, right? A more emphatic realization that we really can't give these away. We've seen there's no other way to live that actually works. I am actually hopeful that I guess one way to say it sounds too idealistic, but I actually believe it could be the case, is that dictatorships become morally obsolete. They become morally unworkable forms of government, and that the crisis that creates is sufficient to force us to find another way.
I think there is genuinely a tough question here, which I'm not sure how you resolve. And we've had to come out one way or another on it through history, right? So with China in the 70s and 80s, we decided, even though it's an authoritarian system, we will engage with it. And I think in retrospect, that was the right call, because it has stayed an authoritarian system, but 1 billion plus people are much wealthier and better off than they would have otherwise been. And it's not clear that it would have stopped being an authoritarian country otherwise. You can just look at North Korea as an example of that, right? And I don't know if that takes that much intelligence to remain an authoritarian country that continues to coalesce its own power. And so you can just imagine a North Korea with an AI that's much worse than everybody else's, but still enough to keep power. And then so in general, it seems like, should we just have this attitude of the benefits of AI will, in the form of all of these empowerments of humanity and health and so forth, will be big. And historically, we have decided it's good to spread the benefits of technology widely, even to people whose governments are authoritarian. And I guess it is a tough question how to think about it with AI, but historically, we have said, yes, this is a positive sum world, and it's still worth diffusing the technology.
Yeah. So there are a number of choices we have. I think framing this as a kind of government to government decision, and in national security terms, that's like one lens, but there are a lot of other lenses. Like, you could imagine a world where, we produce all these cures to diseases, and like the cures to diseases are fine to sell to authoritarian countries. The data centers just aren't, right? The chips and the data centers just aren't. And the AI industry itself. Like another possibility is, and I think folks should think about this, like, could there be developments we can make, either that naturally happen as a result of AI, or that we could make happen by building technology on AI? Could we create an equilibrium where it becomes infeasible for authoritarian countries to deny their people kind of private use of the benefits of the technology? Are there equilibria where we can kind of give everyone in an authoritarian country their own AI model that kind of like defends themselves from surveillance, and there isn't a way for the authoritarian country to like crack down on this while retaining power? I don't know. That sounds to me like if that went far enough, it would be a reason why authoritarian countries would disintegrate from the inside. But maybe there's a middle world where like there's an equilibrium where if they want to hold on to power, the authoritarians can't deny kind of individualized access to the technology. But I actually do have a hope for the more radical version, which is, is it possible that the technology might inherently have properties, or that by building on it in certain ways we could create properties that have this kind of dissolving effect on authoritarian structures? Now, we hoped originally, right? If we think back to the beginning of the Obama administration, we thought originally that social media and the internet would have that property, and turns out not to. But I don't know. What if we could try again with the knowledge of how many things could go wrong, and that this is a different technology? I don't know that it would work, but it's worth a try.
Yeah. I think it's very unpredictable. Like, there's first principles reasons why authoritarianism might be privileged.
It's all very unpredictable. Yeah. I don't think. I mean, we got it. We got to recognize the problem, and then we got to come up with 10 things we can try, and we got to try those, and then assess whether they're working or which ones are working, if any, and then try new ones if the old ones aren't.
But I guess what that nets out to today is, you say, we will not sell data centers, chips, and then the ability to make chips to China. And so in some sense, you are denying there would be some benefits to the Chinese economy, Chinese people, et cetera, because we're doing that. And then there would also be benefits to the American economy, because it's a positive sum world. We could trade. They could have their country data centers doing one thing. We could have ours doing another. And already you're saying it's not worth that positive sum stipend to empower those countries.
What I would say is that, we are about to be in a world where growth and economic value will come very easily if we're able to build these powerful AI models. Growth and economic value will come very easily. What will not come easily is distribution of benefits, distribution of wealth, political freedom. These are the things that are going to be hard to achieve. And so when I think about policy, I think that the technology and the market will deliver all the fundamental benefits, almost faster than we can take them. And that these questions about distribution and political freedom and rights are the ones that will actually matter and that policy should focus on.
Okay, so speaking of distribution, as you were mentioning, we have developing countries, and in many cases, catch-up growth has been weaker than we would have hoped for. But when catch-up growth does happen, it's fundamentally because they have underutilized labor, and we can bring the capital and know-how from developed countries to these countries, and then they can grow quite rapidly.
Yes.
Obviously, in a world where labor is no longer the constraining factor, this mechanism no longer works. And so is the hope basically to rely on philanthropy from the people who immediately get wealthy from AI, or from the countries that get wealthy from AI? What is the hope for?
I mean, philanthropy should obviously play some role, as it has, as it has in the past. But I think growth is always better and stronger if we can make it endogenous.
Yeah.
So, what are the relevant industries in an AI driven world? Look, there's lots of stuff, there's, I said we shouldn't build data centers in China, but there's no reason we shouldn't build data centers in Africa, right? In fact, I think it'd be great to build data centers in Africa. As long as they're not owned by China, we should build data centers in Africa. I think that's a great thing to do. We should also build, there's no reason we can't build a pharmaceutical industry that's like AI driven. If AI is accelerating drug discovery, then there will be a bunch of biotech startups. Let's make sure some of those happen in the developing world. And certainly during the transition, I mean, we can talk about the point where humans have no role, but humans will still have some role in starting up these companies and supervising the AI models. So let's make sure some of those humans are humans in the developing world, so that fast growth can happen there as well.
You guys recently announced Claude is going to have a constitution that's aligned to a set of values and not necessarily just to the end user. And there's a world you can imagine where if it is aligned to the end user, it preserves the balance of power we have in the world today, because everybody gets to have their own AI that's advocating for them. And so the ratio of bad actors to good actors stays constant. It seems to work out for our world today. Why is it better not to do that, but to have a specific set of values that the AI should carry forward?
So I'm not sure I'd quite draw the distinction in that way.
Yeah.
There are maybe two relevant distinctions here, which are, I think you're talking about a mix of the two. One is, should we give the model a set of instructions about do this versus don't do this?
Yeah.
And the other, versus should we give the model a set of principles for kind of how to act? And there it's kind of purely a practical and empirical thing that we've observed, that by teaching the model principles, getting it to learn from principles, its behavior is more consistent, it's easier to cover edge cases, and the model is more likely to do what people want it to do. In other words, if you're like, don't tell people how to hotwire a car, don't speak in Korean, if you give it a list of rules, it doesn't really understand the rules, and it's kind of hard to generalize from them. If it's just kind of a list of do's and don'ts. Whereas if you give it principles, and then it has some hard guardrails like don't make biological weapons, but overall you're trying to understand what it should be aiming to do, how it should be aiming to operate. So just from a practical perspective, that turns out to be just a more effective way to train the model. That's one piece of it. So that, it's the kind of rules versus principles trade-off. Then there's another thing you're talking about, which is kind of like the corrigibility versus, I would say kind of intrinsic motivation trade-off, which is how much should the model be a kind of, I don't know, like a skin suit or something where, you just kind of, it just kind of directly follows the instructions that are given to it by whoever is giving it those instructions, versus how much should the model have an inherent set of values and go off and do things on its own. And there, I would actually say everything about the model is actually closer to the direction of like, it should mostly do what people want. It should mostly follow these. We're not trying to build something that like, goes off and runs the world on its own. We're actually pretty far on the corrigible side. Now what we do say is there are certain things that the model won't do, right? That it's like, I think we say it in various ways in the Constitution, that under normal circumstances, if someone asks the model to do a task, it should do that task. That should be the default. But if you've asked it to do something dangerous, or if you've asked it to to kind of harm someone else, then the model is unwilling to do that. So I actually think of it as like a mostly corrigible model that has some limits, but those limits are based on principles.
Yeah, I mean, then the fundamental question is, how are those principles determined? And this is not a special question for Anthropic. This would be a question for any AI company. But because you have been the ones to actually write down the principles, I get to ask you this question. Normally, a constitution is like, you write it down, it's set in stone, and there's a process of updating it and changing it and so forth. In this case, it seems like a document that people at Anthropic write that can be changed at any time, that guides the behavior of systems that are going to be the basis of a lot of economic activity. What is how do you think about how those principles should be set?
Yes. So I think there's maybe three kind of sizes of loop here, right?
Yeah.
Three ways to iterate. One is we iterate within Anthropic, we train the model, we're not happy with it, and we kind of change the Constitution. And I think that's good to do. And putting out publicly, making updates to the Constitution every once in a while, saying, here's a new Constitution.
Right.
I think that's good to do because people can comment on it. The second level of loop is different companies will have different constitutions. And I think it's useful for like Anthropic puts out a constitution, and Gemini model puts out a constitution, and other companies put out a constitution, and then they can kind of look at them, compare. Outside observers can critique and say, this I like this one, this thing from this constitution, and this thing from that constitution, and then kind of that creates some kind of soft incentive and feedback for all the companies to like take the best of each element and improve. Then I think there's a third loop, which is society beyond the AI companies and beyond just those who kind of who comment on the constitutions without hard power. And there, we've done some experiments. Like, a couple of years ago, we did an experiment with, I think it was called the Collective Intelligence Project, to like, to basically poll people and ask them what should be in our AI constitution. I think at the time we incorporated some of those changes. And so you could imagine with the new approach we've taken to the Constitution doing something like that. It's a little harder because it's like that was actually an easier approach to take when the Constitution was like a list of do's and don'ts. At the level of principles, it has to have a certain amount of coherence. But you could still imagine getting views from a wide variety of people. And I think you could also imagine, and this is like a crazy idea, but hey, this whole interview is about crazy ideas, right? So, you could even imagine systems of kind of representative government having input, right? Like, I wouldn't do this today because the legislative process is so slow. Like, this is exactly why I think we should be careful about the legislative process and AI regulation. But there's no reason you couldn't, in principle, say like, all AI models have to have a constitution that starts with like these things, and then like you can append other things after it, but like there has to be this special section that like takes precedence. I wouldn't do that. That's too rigid. That sounds that sounds kind of overly prescriptive in a way that I think overly aggressive legislation is. But like that is a thing you could that is a thing you could try to do. Is there some much less heavy-handed version of that? Maybe.
I really like control loop too, where obviously this is not how constitutions of actual governments do or should work, where there's not this vague sense in which the Supreme Court will feel out how people are feeling and what are the vibes, and then update the Constitution accordingly. So there's with actual governments, there's a more procedural
formal process.
Yeah, exactly. But you actually have a vision of competition between constitutions, which is actually very reminiscent of how some libertarian charter cities people used to talk about what an archipelago of different kinds of governments could look like, and then there would be selection among them of who could operate the most effectively, in which place people would be the happiest. And in a sense, you're actually there's this vision
I'm kind of recreating that.
Yeah, like this like utopia of archipelagos.
Again, I think that vision has if things to recommend it and things that will kind of go wrong with it. I think it's an interesting, in some ways compelling vision, but also things will go wrong with it that you hadn't imagined. So I like Loop 2 as well, but I feel like the whole thing has got to be some mix of loops 1, 2, and 3, and it's a matter of the proportions, right? I think that's got to be the answer.
When somebody eventually writes the equivalent of the making of the atomic bomb for this era, what is the thing that will be hardest to glean from the historical record that they're most likely to miss?
I think a few things. One is, at every moment of this exponential, the extent to which the world outside it didn't understand it. This is a bias that's often present in history, where anything that actually happened looks inevitable in retrospect. And so, I think when people look back, it will be hard for them to put themselves in the place of people who were actually making a bet on this thing to happen that wasn't inevitable, that we had these arguments, like the arguments that I make for scaling, or that continual learning will be solved. Some of us internally in our heads put a high probability on this happening, but it's like there's a world outside us that's not acting on that's not acting on that at all. And I think the weirdness of it. I think, unfortunately, like the insularity of it, like, if we're 1 year or 2 years away from it happening, like the average person on the street has no idea. And that's one of the things I'm trying to change, like with the memos, with talking to policymakers. But like, I don't know. I think that's just like a crazy thing.
Yeah.
Finally, I would say, and this probably applies to almost all historical moments of crisis, how absolutely fast it was happening, how everything was happening all at once. And so decisions that you might think, were kind of carefully calculated, well, actually, you have to make that decision, and then you have to make 30 other decisions on the same day, because it's all happening so fast. And you don't even know which decisions are going to turn out to be consequential. So, one of my, I guess, worries, although it's also an insight into kind of what's happening, is that, some very critical decision will be some decision that, someone just comes into my office and is like, Dario, you have 2 minutes. Like, should we do thing A or thing B on this? Like, someone gives me this random, half page memo and is like, should we do A or B? And I'm like, I don't know, I have to eat lunch. Let's do B. And that ends up being the most consequential thing ever.
So final question. It seems like you have, there's not tech CEOs who are usually writing 50-page memos every few months. And it seems like you have managed to build a rule for yourself and a company around you, which is compatible with this more intellectual type role as CEO. And I want to understand how you construct that, and how does that work to be, you just go away for a couple of weeks and then you tell your company, this is the memo, like, here's what we're doing. It's also reported you write a bunch of these internally.
Yeah. So, I mean, for this particular one, I wrote it over winter break.
Yeah.
So there was the time, and I was having a hard time finding the time to actually write it. But I actually think about this in a broader way. I actually think it relates to the culture of the company. So I probably spend a third, maybe 40% of my time making sure the culture of Anthropic is good. As Anthropic has gotten larger, it's gotten harder to just, get involved in directly involved in the training of the models, the launch of the models, the building of the products. Like, it's 2,500 people. It's like, there's just, I have certain instincts, but there's only, it's very difficult to get involved in every single detail. I try as much as possible. But one thing that's very leveraged is making sure Anthropic is a good place to work. People like working there. Everyone thinks of themselves as team members. Everyone works together instead of against each other. And, we've seen, as some of the other AI companies have grown, without naming any names, we're starting to see decoherence and people fighting each other. And, I would argue there was even a lot of that from the beginning, but that it's gotten worse. But I think we've done an extraordinarily good job, even if not perfect, of holding the company together, making everyone feel the mission, that we're sincere about the mission, and that, everyone has faith that everyone else there is working for the right reason, that we're a team, that people aren't trying to get ahead at each other's expense or backstab each other, which again, I think happens a lot at some of the other places. And how do you make that the case? I mean, it's a lot of things. It's me, it's Daniela, who, runs the company day to day. It's the co-founders, it's the other people we hire, it's the environment we try to create. But I think an important thing in the culture is the other leaders as well, but especially me, have to articulate what the company is about, why it's doing what it's doing, what its strategy is, what its values are, what its mission is, and what it stands for. And, when you get to 2,500 people, you can't do that person by person. You have to write or you have to speak to the whole company. This is why I get up in front of the whole company every 2 weeks and speak for an hour. It's actually, I wouldn't say I write essays internally. I do two things. One, I write this thing called a DVQ, Dario Vision Quest. I wasn't the one who named it that. That's the name it received, and it's one of these names that I tried to fight it because it made it sound like I was like going off and smoking peyote or something. But the name just stuck. So I get up in front of the company every 2 weeks. I have like a 3 or 4 page document, and I just kind of talk through like 3 or 4 different topics about what's going on internally, the models we're producing, the products, the outside industry, the world as a whole as it relates to AI and geopolitically in general, just some mix of that. And I just go through very, very honestly. I just go through and I just say, this is what I'm thinking. This is what Anthropic leadership is thinking. And then I answer questions. And that direct connection, I think, has a lot of value that is hard to achieve when you're passing things down the chain, six levels deep. Large fraction of the company comes to attend either in person or virtually. And it really means that you can communicate a lot. And then the other thing I do is I just, I have a channel in Slack where I just write a bunch of things and comment a lot. And often that's in response to, just things I'm seeing at the company or questions people ask, or like, we do internal surveys and there are things people are concerned about. And so I'll write them up. And I'm very honest about these things. I just say them very directly. And the point is to get a reputation of telling the company the truth about what's happening, to call things what they are, to acknowledge problems, to avoid the sort of corpo speak, the kind of defensive communication that often is necessary in public because, the world is very large and full of people who are, interpreting things in bad faith. But if you have a company of people who you trust, and we try to hire people that we trust, then you can really just be entirely unfiltered. I think that's an enormous strength of the company. It makes it a better place to work. It makes people more of the sum of their parts, and increases the likelihood that we accomplish the mission because everyone is on the same page about the mission, and everyone is debating and discussing how best to accomplish the mission.
Well, in lieu of an external Dario Vision Quest, we have this interview.
This interview is a little like that.
This has been fun, Dario. Thanks for doing it.
Yeah, thank you, 𝐿𝐿𝐿.
Hey, everybody. I hope you enjoyed that episode. If you did, the most helpful thing you can do is just share it with other people who you think might enjoy it. It's also helpful if you leave a rating or a comment on whatever platform you're listening on. If you're interested in sponsoring the podcast, you can reach out at dwarkesh.com/advertise. Otherwise, I'll see you on the next one.